Thanks. It's a pleasure to be asked to participate in the workshop and also to participate in the session on data sharing, although I'm usually on the side of the cheerleader for rapid, broad access and data sharing, and I was asked to talk about protections and issues raised by broad data sharing. So I kind of feel like I'm on a high school debate team, and I was asked to take the opposite side of what I normally believe, and I'm also not a technology expert in data security. So I started by reading the work group reports, and the EHR work group had this statement in it, and that is that they thought we won't need to do not believe that any new or unique cybersecurity measures will need to be developed specifically for the project, but adoption of industry-wide best practices and technologies and ongoing vigilance. So I read this and said, okay, I'll just show this slide and I'm done. Everybody should just follow best practice guidelines. And then I thought about it, and from my particular perspective as a clinical laboratory person who does research on clinical data, I'm often reminded of the different standards between a clinical laboratory and a clinical health system and the research community. So which best practices are we talking about when we say we're going to follow them? Is that clinical best practice or research best practice? And yesterday we heard comments about research grade phenotype implying it was higher than clinical grade phenotype from the EHR in that particular example. From my viewpoint, clinical laboratory genetics data is always a higher standard than research laboratory genetics data. So depending on which data you're talking about, the standard may be higher on the research side or the clinical side. And then we all know that healthcare lags behind every other industry sector and technology, so this is probably not an exception in terms of security and privacy, so we need to not be limited to looking at our healthcare and healthcare research best practices. And of course, we don't want to be US-centric, but think about international standards in all of this. So how do we choose, and do we have the luxury, and can we afford to choose the highest standard, no matter what it is, but at least we should be aware of what all those best practices. The other thing I'm sensitive to as a clinical lab and a research lab person is the training of the personnel and credentialing of the personnel in those two environments is remarkably different. And so in terms of HIPAA privacy, data security, do we do as well in a research setting as we do in a clinical healthcare setting? Are the monitoring audit procedures, again, of the behavior of the people and use of data the same? And then the consequences. You heard at the end of Rory's talk the comment about the consequences of inappropriate use of data. This came up briefly yesterday in the discussion. And I think in a healthcare setting, the consequences of inappropriate access and use of data are severe. In a research setting, it's usually a hand slap or some other relatively minor consequence. So what should it be when we're dealing with participants' health information and genetics information? Yesterday afternoon, we had a great session from the participant engagement group, and Dixie Baker walked us through fair information practices and different recent US implementations of that, and told us that there were 10 consistent principles across different implementations of this by US agencies. I've highlighted here data quality because I'm going to come back to this as a concern I've always had on the laboratory side. I think it's a broader concern in other clinical areas. Security through reasonable safeguards, again, which standards are we using, and accountability. And then Sharon Terry talked about the peer platform creating an environment of trust, and particularly emphasized the ability of participants to set their preferred privacy directives, which information to allow, which to prohibit, and which to check in with them and ask them whether they wanted to share that particular data. At Geisinger, We view ourselves as a model of what the IOM and many other organizations have talked about in terms of a learning health system and trying to reintegrate clinical research with clinical care and break down the arbitrary walls and obstacles to learning. And this is, there are many types of illustrations of the process of continuous learning and taking every routine clinical encounter as an opportunity to collect data and learn towards the goal of improving care and improving outcomes of the next patient that comes through. At Geisinger, we have a broad engagement framework for individual patients, families, and communities that's outlined here. A little bit complicated, but at the top shows a care continuum. And to the far right, our goal is shared decision-making and participation by the patient in their health care. In the middle indicates our quality control, quality improvement activities, care improvement, and to the far right, the goal of patients as co-leaders and participants in quality improvement. In the bottom, blue-purple colors are discovery or research in a learning health system environment. The far right represents the PCORI model of patients as co-investigators in designing research and discovery projects as well as being participants. Further, in our own biobanking and now genome sequencing project, which you've heard alluded to in our partnership with Regeneron, we started our biobank in 2007, have always had a goal of leveraging our clinical infrastructure for efficiency and other reasons. So after informed consents, we don't do a research blood draw. We put an order into the electronic medical record that every time the patient has a blood draw for a clinical purpose, an extra tube is drawn and sent to the genomics core. This is all done in a CLIA clinical environment using our regular clinical lab medicine pathology department, and then stored in a genomics biobank that also lives in a CLIA environment. Now, the process is not totally CLIA. It's a modified CLIA because at the moment we send out our exome sequencing for our research project to Regeneron. We retain a sample in a CLIA-protected environment and will confirm any positive results in clinically actionable genes through a CLIA laboratory confirmation on the sample that was always in the protected CLIA environment. So it's trying to come as close to a full CLIA operation. I'll raise the question now and later at the end of my talk, should we be moving towards all components of this, including the sequence information being generated in a CLIA lab environment? As you know, whole exome sequencing is now offered on a clinical basis, and in some cases, whole genome sequencing on a clinical basis in a CLIA lab environment. I'm of the opinion that this will rapidly move into clinical testing, and in a learning health environment, that means you just need to be prepared to catch that data that's a byproduct of routine patient care and store it in a research accessible and useful way. At the moment in our partnership with Regeneron, which now has a goal of whole exome sequencing on at least 250,000 patients, the raw data and other genomics data goes directly to a cloud-based environment using the DNA Nexus platform. I show this because they have all these acronyms for various security levels for the Amazon Web Service, which is HIPAA compliant, FISMA compliant, ISO 27001 compliant. The DNA Nexus platform itself is ISO 27001 compliant. And then various customers and users have their own CAP, CLIA, HIPAA, et cetera, compliance. Again, I'm not a technical expert, but I can say when the discussions about data security for the genomics data on our patients was held between the technical experts at DNA Nexus and Amazon Web Service with our ultra-conservative, paranoid IT and data security people at Geisinger, they were convinced that it was okay for us to conduct this research project. We're actually using it as a pilot project to think about the future of cloud-based computing for the healthcare system as a whole based on the initial positive experience and sense of reassurance on the security issues. We're doing pilot projects now with DNA Nexus, putting de-identified clinical data in the cloud to facilitate the ability to compare genomic, large-scale genomic and clinical data. And in another project that we're involved in, the Clinical Genomics Research Project funded by NHGRI, which is a large-scale project aimed at collecting and doing evidence-based curation and review of data to determine what genomic variants are clinically relevant and what are benign. It's a large, complex project, but it collects data both directly from patients, participants, clinicians, laboratories, clinical laboratories, and research laboratories. We've recently developed and implemented a patient portal called GenomeConnect, whose purpose is to allow patients who have genetic testing and genetic test reports can upload their own genetic test reports, which are then reviewed and curated by expert medical genetics and genetics laboratory people to add to the total database in this project. In that project, where everything is done in a HIPAA compliant way, it sits on a patient crosswords platform, which is moving towards FIMSA compatibility as well. And this just comments on the patient crossroads platform that this is performed on. It raises questions about this particular project and what is the right data security, data technology platform for this. And again, I'm not the right expert, and just raising this for discussion and consideration by the group in terms of various US international standards for health data, clinical environments, as well as research data. The other thing I wanted to comment briefly on is, again, training of personnel. Like most healthcare systems, all of our employees, including all of our researchers, go through extensive goals course training on a variety of topics that seem endless. HIPAA is one of those that we go through, extensive training. And then in a healthcare setting, the inappropriate use of data or accessing your own medical record or somebody's medical record that you're not supposed to be accessing has severe consequences, and that is termination, which can be immediate, and can expose you to civil and criminal prosecution. So again, coming from a clinical laboratory background where there were best practice guidelines, extensive training, I have many times had to dismiss employees who breach protocol in a way that they're terminated immediately. So I'll leave you with some closing questions here around data quality, and that is, should all biospecimen collection, handling, storage be in a CLIA/CAP certified biobank environment? This CLIA protection of samples is critical, of course, for the ability to return results and to be confident that you're returning not so much the right result, but the result to the right patient, since sample mix-up is the biggest problem, sample handling and sample mix-up in most laboratory environments. And should all genome sequencing data be generated and analyzed in a CLIA/CAP environment? And as I said, I believe that I won't put a timeline on it, but increasingly this type of genome sequence data will be generated as a byproduct of routine clinical care. For the data security and privacy, I hope some of the other experts in the audience will make comments after this in the discussion session. I simply raise the question of which best practices, and certainly we should be aware of the different standards and look at the cost-benefit ratio of behaving at different best practice levels. And we should at least think about training of personnel, the audit procedure for access of data, and the consequences of security breaches or misuse of the data. Thank you very much.
Thank you, David. Rory, you want